Hello, everyone. My name is Daniel Herzig. I'm Chief Operating at Metaphacts, and I'm happy that you all joined here this hands-on tutorial where you can actually participate with the title and the goal to empowering business users with AI agent-driven insights based on an enterprise knowledge graph that provides trust and explainable answers. All right, we have a packed agenda, starting with a brief intro. We're talking about Gen AI and KG. Surprise. And then I'm going to introduce our AI agent platform Metis on top of our knowledge graph platform Metafactory. And then we go into an hands-on tutorial, starting with a scenario that mimics a real-world enterprise knowledge graph. It's a tiny one, it's a tutorial. And then we're going to see how a conversational AI interface can be configured on top of that. Going to see how we can scope it to a certain domain of the business or to a certain area of the business. We can see how results are traceable and explainable. Some ideas of how it can be optimized further, and then also some topics on quality control, evaluation, and monitoring. Then we have a brief outlook on how is something missing, federated AI, and summary, and also a demo, if we have the time, on a big knowledge graph with a conversational AI interface. All right, then brief intro, very brief one into Metafacts and what we do. So we are a company based in Waldorf, Germany. We are 10 years old now. We developed one product called the Metafactory Knowledge Graph Management Platform that allows you to build a knowledge graph that build models, ecologies, taxonomies, vocabularies, bring them together, build applications on top, and now also get your AI agents working on top of it. Since 2 years, we are part of Digital Science, larger group, and we're working on digital assets and supporting researchers. And we have a team across the globe working and helping our customers to roll out Metafactory and get their use cases running using a knowledge graph based on Metafactory. All right, good. We have all seen Gen AI, ChatGPT, and we have all been fascinated what to do and achieve with those technologies. Really amazing. You type in a question, you get a result back. And we have all been impressed by the power and the potential that we see in this technology. And all of us also have seen sometimes answers that maybe even funny, that they were widely shared on social media because they were so absurd and off from reality and truth. But sometimes the answers were also like, really, is this true? I couldn't say. Maybe it is. Wasn't really sure. Can I really trust it? We really wanted to make decisions based on these answers. And obviously, there's one gap in this technology. The answers that you get, they're not explainable, right? They're coming out of a black box, and you don't know how this answer was derived, and also not really what was the basis that this answer was derived on. Furthermore, if we are now in an enterprise context, they cannot answer questions specific to your enterprise data because it doesn't have it, and we don't want to give it to them, right? So I think we have a lack here. On the other hand, we have the knowledge graph. This is actually the perfect counterpart to it. It's a very explicit representation. We can actually understand how results are retrieved from the knowledge graph. It's very tangible, it's interpretable, it's explainable. So why don't we bring those two words together and make the best out of it? This is what we are trying with our agent framework Metis that I'm happy to show you today and that we're going to try out. All right. Why is this so important? Well, AI, as we have seen with the Gen AI alone, if you don't have any context to it, it's just guesswork, right? We have this no explainability type. We have no transparency how answers are generated. We see the potential of the data in terms of language understanding and working with language and detecting user intents. But we saw hallucinations. We saw problems with this. The lack of traceability and explainability, and also not the scoping to a certain kind of area. And domain. If you employ this in a business, you will want to get answers for a certain area and not everything left and right, because you want to be sure that the users use it for a dedicated purpose. Okay, addressing these topics, we clarify maybe first, what is an AI agent? It's not a chatbot. An AI agent is really an autonomous agent that can act and pursue a goal and make certain decisions along the way. So the agent understands the user intent, the goal of the user, and is then able to do some planning in order to achieve this goal. In terms, for example, using different kinds of tools, remembering certain steps along the way, and also collaborate maybe with other agents or other APIs and other tools to achieve the goal. So why do agents need to be knowledge-driven? Our answer to this is the Metis framework that sits on top of Metafactory, our knowledge graph platform. This platform allows you to configure AI agents. That's what you're going to do here in the tutorial. They connect to a large language model and make use of it. And then they can be configured and make use of tools for certain tasks. We connect this slide to what we have in Metafactory. Very central to this is the semantic model, is the ontology. The ontology provides the scope and the domain that the agent operates in and describes the area that the agent can answer questions on. The agents only answer questions that are in the domain, in the context of a specific ontology. And obviously, this ontology can describe and describes the knowledge graph that we have, which might reside even in different databases, and can then answer questions against this, using this semantic model to the user. And thereby, we have two things. We have explainability, because we see what the answers are that come from the knowledge graph and that are grounded in the knowledge graph. Since we trust our own data, we assume that by showing that the answers come only from this data, we can also establish trust in the answers that the agent derives. Looking a little bit more in detail into it, what does Metis do? So we have agents. We can configure several of them for different tasks using different language models. We in the platform have already usages for modeling and vocabulary coming up, vocabulary mappings coming up. And we have a conversational AI interface that allows us to interact and have a conversation with the agent. The agent then uses our Metis platform. There's certain capabilities derived from the large language models and can use certain tools in order to achieve the goal. Okay, then let's start into our tutorial section. Okay, let's assume the following scenario. So we are in a very large organizations. Our usual customers are very large organizations. So we have many departments. Each department has certain data, works on certain data. They have the ownership about their data. And obviously, they're using also data from other departments. Right? So very common scenario. So in our example, for example, we have an HR department, we have finance, we have a project management office. They have their data and they're working with that. So, and now we want to basically ask questions over this data. And there's lots of data awaiting enterprise. Yeah? Usual scenarios, you have data catalogs, you have business glossaries, you have data governance tools, you have business process modeling tools, you have master data management tools, and so on and so on. And all of them contain certain parts of the puzzle. Yeah? All of them contain data that is essential to ask business critical questions. And obviously, a knowledge graph is perfect to address the problem of data integration, of bringing this data together in order to answer those questions. In our scenario today, we are starting to achieve one goal. Yeah? Let's all assume we are a CEO, maybe CDO, CIO, CDO, whatever. We are a person who wants to know certain things. For example, who works on the Blue Sky project? What is the budget for the Blue Sky project? What are the skills required? Yeah, maybe you have a set of questions that you want to have answers for, but you don't have any technical knowledge. You don't know the data model. You don't know the structure of it. You don't know the location of the data. You are very time constrained. You have no time to do running around for all of this by yourself, but you want to have trustworthy answers that you can rely on and make business decisions. And obviously, you also want to understand the underlying basis of those answers. Yeah? What was used to derive the answers and what was supporting the answers. And the traditional way here is that, well, okay, I'll ask a business analyst to create a report. Business analyst starts, collects data from different pieces, puts them together, and files a report with listing all those questions. So let's see if we can achieve this. And instead of using a business analyst, achieves this by configuring an AI agent to do this. And here I'll give you a second to log into your Metafactory instance. You have to sign up for it. If you start at your Metafactory and if you log in, you see this start screen and you have two options. On the left-hand side is what I would call the yellow tutorial. That's a self-guided tutorial that explains the basis of our platform, how to create an ontology, how to work with data, how to create a vocabulary, how to map things. And this is something that you can do whenever you want. Self-guided, it has videos in it, and so on. If feel free to try it out. We are starting today here. Don't already have a prepared scenario for us. It's focusing on the AI part only. All right, good. So this should look like this for you as well. Good. So let's remember we are starting out in our scenario. We're joining here the red tutorial. And please remember our enterprise scenario, right? We had different departments. They are working on their own data. They are modeling their own data. We want to have an enterprise knowledge graph and in the end ask questions across it. So how would we do this? Yeah, let's have a brief intro into the scenario and then we're going to start into it. So we start out with an enterprise ontology. Yeah? Maybe very abstract things, concepts that we have that are important for our business that we can all agree on without much debate. Yeah? So for example, we say we have budgets, we have projects, and we have persons. Very generic, very simple. Persons have first and last name, project has the description, budget has an amount. Okay, very simple. This is the very abstract starting layer that we start out with. And now we said we are in a large organization where we need to distribute the task because it's not going to work out that one team is going to model an ontology for the entire enterprise. And we need to distribute it to the different teams. So we go and start, for example, for person and say, hey, please, HR department, please take care of this. And you are the owners for person. Please model your ontology the way that you want, that you need, with the things that are important for your tasks. Yeah? So they're starting out and they're modeling. And we have contractors, we have employees, and the people, they have skills. And for the skills, you can see there's small here. They have issues of vocabulary restrictions. So skills actually come from a controlled vocabulary that we make use of here in this ontology. If you're interested in how ontologies and vocabularies can be connected, that's something you see in the yellow tutorial. Okay, so HR department did that job. Then we have the same for the finance department and for the project management department. They also got the abstract class from project, from the enterprise ontology, and then they said, okay, well, we have internal projects, support projects, customer projects, and we have projects that have budgets, and then actually expenses are booked on a budget. Okay, so also they did their job. Obviously, this is not just covering here let's say the schema, the ontology abstract level. This also means that these departments working on their instance data. So if we go, for example, go back to the ontology and say, let's see, we have employees, and we go to the top right here, manage instances. You also can see that the HR department, they manage the instance data. In our tiny example, the data can be maybe even created via a simple form with first name, last name, and then some skills that the person had when they were hired. Those forms, by the way, are all model-driven. So when you extend the ontology, all those forms are automatically also extended and they evolve with the ontology. That's what we call model-driven application development. Okay, obviously in large enterprises, you have already systems out there and you would have an ETL pipeline to ingest large volumes of data into your knowledge graph. You wouldn't do it all by forms. But here in our scenario, we have each department working on its model and data. All right, perfect. So now we have distributed data modeling, distributed data management. Now we want to go back in our CEO position and ask questions across the whole thing. Therefore, if we now, in this case, don't want to scope it to, let's say, one department, but to all of them, we go and start out and we create a new ontology. Call it here, for example, the CEO AI interface application ontology. And in this ontology, we don't actually define anything new. All what we do is we import the ontologies from the different departments. Because they did their modeling, then we just import the HR ontology, project management ontology, the finance ontology. We're just basically harnessing the work from the distributed modeling. But then what do you see? Well, we have now an integrated model for projects that persons work on, with employees, contractors, projects, and we have budget with expenses. Okay, so this is the scope of the AI agent that we now want to configure and that we want to start out with and use. So if we now have a look at the tiny tutorial example enterprise knowledge graph that we have here, then you see we have employees, we have John, Bob, Jane, Alice. They have skills, time management, working with shape and spaces, manage quantitative data. They are members of certain projects. These projects have budgets, and the projects also have certain data, like they have a start date, they have an end date, they require certain skills, they have a description. Yes. All right. So it's a very tiny knowledge graph, I admit, just serving here the purposes for our tutorial so that we can easily grasp it, easily can ask questions against it, and easily validate also if the questions that we, or the answers that we get back make sense to us. Okay. So now let's start and configure our agent. Before we do this, let's have a brief look at the architecture. So we have Metafactory, and then in Metafactory we have our meters. On top of Metafactory, our meters framework is the AI agents. We have an LLM that we connect with, and be physics, any kind of LLM that you want to use. So we have connectors for OpenAI, Azure AI, Mistral, Olama, and a few others. You're free to choose. You can configure one or even several of that. Then we have the agent part. The agents have several tools available: entity linking, Sparkle translation, execution, LED descriptions, so on. And the agents can be configured to make use of one or all of the tools, and the tools can also be configured and tailored to specific use cases. And then you have an conversational AI interface that basically allows you to communicate via interface with the agent. Yep. So it's a very simple setup. What we need to do is we configure a large language model, we configure our agent, and then we configure the user interface. And if we just, what we do now here in the tutorial, start out with the out of box, that means we need only to provide an API key here. We need to provide an ontology IRI here. And we need to copy paste the conversational AI component on a page to make it work. So let's have a look and see this in action. So very simple. If I go here to AI services, you're all administrators, so you have all rights. You can do everything in the platform. On AI services, you see here our overview of the configured services. In this case, there are already two configured. One is in this case, you're making use of the OpenAI language model. And then we have one agent, conversation agent configured. Now, if you look into the display, correct? How do you get the display? You click on the top right on the gear icon. Then you are in the administration overview. And at the bottom, there's this AI services. And you could configure more, right? You can configure at the same time several different large language models. For example, if you want to compare performance of tools. And also you can configure several agents using the same large language models. If you, for example, want to configure them for different tasks or for different ontologies, different scopes. Okay, yeah, so the setup here is not much to see, very simple. An AI key and then some parameters. Usually out of the box is fine. Tuning them is then really an advanced task, I would say. And for the agent, everything that we did here is, for example, here using the RI of the ontology that defines basically the scope and the model that we provide to the agent in order for the agent to know what kind of questions can be answered. Good. So now we have set it up. And now we can start to the interface. If you go on the start page of the tutorial, to the bottom left, there's a link conversational AI interface. And if you click on this, we're getting to the conversational AI interface. This one here is already configured for our tutorial scenario. But if you click on edit page, you can see that it's very simple. All what I did here was basically providing some example queries that we can run. Now let's do this. Yeah? So we are now in our scenario. We have our enterprise knowledge graph. Now we want to ask questions. And we as CEO, for example, want to know who works on the Blue Sky project? We're typing in this question. This question is now interpreted and sent to the large language model that detects the user intent. The agent then chooses what kind of tools do I want to use to answer this question, and then comes back with an answer to us. Sometimes this takes a while. The LLM needs to respond. We're sending a few things back and forth. The query that comes back is verified, validated, and then executed. Now we see here the agent responded with the following people work on the Blue Sky project, and we see here Bob Miller and Alice Wonderland. Yeah? Let's briefly verify this in our simple scenario. If we go here and click on hover over the Blue Sky project, you can actually see that Bob Miller and Alice Wonderland is the correct answer. Just to verify this. But what we also see is that all entities involved in the answer are actually links into the knowledge graph. So I can click here on this Blue Sky project and then jump to this particular node in the knowledge graph, also actually see, is this what I intended? Yeah? Is this the thing that I'm interested in? And I could then explore more about it and understand the context. Yeah? And the same is obviously true here for Bob Miller and Alice Wonderland. Everything is grounded in the knowledge graph. The whole result, the whole answer that I got comes from the underlying knowledge graph. Okay, good. I promise you that when you get a result, you can also understand and trace the result, how they was derived. And this is if you expand this chevron here, right next to the conversational AI, you actually see what kind of tools the agent used. Now, yes, the entity linking was used in Sparkle translation and Sparkle execution. And if you want to dive even deeper, you can click here on the detailed information. And then you can see that the entity linking actually discovered this term Blue Sky project here. And then you can see that the Sparkle translation tool used this as an input. Also, obviously, having the ontology as background information available in order then to write the Spark query for us, where we'll see that we have here a project, and the project has members, and from the members we want to have and then we have this here, and then we execute this and then render this here as a table. We can now have a conversation and actually say, okay, person is enough. I see the label here already on the IRI. I don't need last name and first name. I can just say then remove columns 2 and 3. And then I get a result that interpretation of the result, the previous result, adjusted to what I intended now here, and I get the results. So I can actually also transform the results. I can also add more info to it if I'm interested in it. So we can clear the chat and start a new one, because if we would just ask new questions, we could do this. But we always have the context, right? It's a conversational agent. That means previous answers and previous results are taken into context for subsequent questions. Yeah? And now I can answer questions that are more difficult. For example, which projects are running right now? The interesting part of this question is that this has a temporal aspect to it. Now is a point in time, and our knowledge graph was created maybe a while ago. So this is something, it's a temporal aspect that we have in here, and we now see the following projects are currently running, and there's the green jungle project and the red carpet project. And if you look now at the translation here, we can actually see that this running right now was interpreted and translated into something where the start date is in the past, but the end date is in the future. Okay. And obviously, I can also ask, or let's say, maybe we ask a question where we now say, okay, we had now the HR department, where we said the HR department takes care of employees and their skills. And the project management office, they are taking care of projects. And the projects also require certain skills. So maybe we just ask the agent a question, for example, who has skills needed for the Blue Sky project? Yeah. So basically now we are bringing data together from both departments, or at least we ask for it. I hope it works. I don't want to lie with the LLMs are not deterministic. So you run a query 10 times and 9 times it works well, and at 10 times it does not work.
We all on demos on LLM.
I can tell you, if my doctor asks me what I do for cardio, I say I do live demos with LLMs.
You've never been as nervous doing a demo with an LLM.
Okay, good. And now we have a result here, right? So the following people have the skills needed for the Blue Sky project. And we can see that now John, Jane, and Alice have been returned as a result. We could look this up here again in the query that if you understand Sparkle, you can understand that here's the project. The project, it was injected the IRI for Blue Sky. And you can see the skills that the project requires. And then we have here persons that have actually the same skill that match here. And yeah, we can also say, well, show me the skills and ask some questions further on that.
Refuse to answer a question about Jane Doe. That how many projects does Jane Doe work on? And said I couldn't find any specific information about Jane Doe in United.
Okay. So, well,
I can't be right. I did.
Okay. Yeah, I mean, honestly, if you try out things, sometimes queries don't work. Maybe you reformulate, or sometimes you just say try again. That's to be absolutely honest. You have hands-on on the tool. You can try it out. Okay, I try another one. For example, let's go into maybe numeric things. What is the budget for Blue Sky? So we ask now for a specific fact in the knowledge graph. And we get here, okay, the budget for Blue Sky is 1,000. But maybe I want to say, show me, because I want to set this into context of other projects that are working there. Yeah. Show me the budget of all projects as a bar chart. We're now asking not just give me a single answer or a textual answer back, or maybe a table, but now we want to actually also have a visualization. And here we tap into the features that we have within Metafactory, where we have components for all kinds of graph visualizations. There we have visualizations for charts, for graphs, for all kinds of different components that you can now make use of with the agent. Yeah? At the moment, I think it's charts and graph visualizations, but obviously you have the view here, as I said. This is the beta version, the correct term, Johannes? Yeah, okay, beta version. The GA version comes with the next release in July, when it will be a product feature, or will be a product on top of it. Okay, so here we have the bar chart, and we can see our Blue Sky project actually down here. The others got a lot more money, but we can also say, well, make it a donut. Yeah. If I say, okay, bar chart maybe doesn't really show what I'm interested in, or doesn't bring it across, maybe this visualization better serves my purpose. And now we have a donut chart where I can see that here is my Blue Sky project, and here are the budgets of the other projects. Yeah. All right. And you could ask me, what's the highest project budget and so on, and all kind of question in this direction. Good. Any questions?
So I asked, who knows the most about people who start? Yeah, it came back and said, Alice Wonderland knows the most about the Skype project with 6 skills.
Okay.
So then I asked, okay, how many skills? Bob Miller is also on. Asked how many skills he had. It says he has 2 skills. But is that answering my question?
Yeah, good question. I don't know. Maybe not. So, I mean, there is the option.
Is that the type of thing which the system could answer? Like, because I could see a CEO wanting to know that. Oh, there's
absolutely.
I'm on the airport, about to go to Frankfurt. I need to know. I don't need to know the top guy on the organizational chart who may not know anything about this. I know that like a 15-minute conversation who knows all about it.
Yeah.
So I don't really care how many skills he has.
Yeah. So I agree. I mean, there are various. But do you want to take the question? Or do you want?
Yeah, I just want to say, I mean, this is what your ontology currently doesn't cover. So you haven't defined explicit semantics for that. which means you are landing in the more vague interpretation space of the LLM.
Yes.
Technology making it explicit, and you're thinking over to getting a more concrete answer on those, which obviously is a trade-off of how much you want to formalize and specify there.
No. So what
You said earlier that the LLM would only answer questions that the ontology knows about. So that's not true because then
okay.
I think so. I answered some far off questions and it did a very good job saying, I don't know who's going to win Eurovision.
Okay. So what I meant with this is that the result is always a Spark query that you can run against the database, and it will always return the results of the database. So the intermediate step is always a Spark query that the agent produces. Yeah. And maybe if the Spark query is off from your intent, well, that's something we're going to see in a second. I said to you there's something about quality control and evaluation coming up that we're going to look at. But yeah, there are also, it's still better. We are still working on it to improve it. But sometimes it could create, in particular, if it's about aggregates, there's something we're still working on, sometimes make mistakes in this direction. Yeah. All right. Maybe this is a good point to, well, let's also, I think, did we see this? No, maybe you can just say, okay, which skills are required for the Blue Sky project? Show me a graph. You can also invoke a graph visualization by the conversational agent to basically start an exploration and see the surroundings of the Blue Sky project, see skills, and then also discover further things from here. So you can basically say, show me parts of the knowledge graph in an explicit visualization. Okay, good. So we have seen you can ask lots of questions about it. And we have also seen that this part, let's jump briefly back into the slides. We have seen this, how that we can see answers across different ontologies and data domains from different teams, chart visualizations. And you already did some exercises, so already asked some questions. So feel free to continue that, and happy to also discuss and get your feedback. That's something you also want to learn to improve it. Okay, we have seen how we can trace the results and see and explain it. So at least if you have some Sparkle knowledge, you can see those parts. And now we have seen sometimes it doesn't work, right? At the moment, there's basically zero optimizations into this. If you spend some time, you can, all of the agents tailor them to specific tasks. And one of the things that maybe a follow-up on the keynote that we had by Mark Musen this morning, where he said, okay, is human knowledge engineering still needed? This is a very good example of why it is, because if you add descriptions to your ontology elements, and if you have a really good ontology where you describe the elements that you have, the LLM makes use of this. The LLM sees those descriptions and can, with the language understanding capabilities, make use of this to derive better results. So maybe if for some of those questions, if we had better descriptions around this, we would be able to answer.
So following on that, if in the ontology you had defined something like numbers of hours worked on a project, so if that was in the ontology, and then this gentleman's question, who knows about this project, was asked, perhaps it would be smart enough to understand that it should also pull number of hours in addition to related skills.
Could be.
Is that what you're saying in terms of enhancing?
Could be, but also a description. So for example, we had this, I think I asked the question, what is needed for? And in the ontology, the relationship was actually a project requires skills, right? So this translation did the LLM by itself.
Right.
But sometimes, for example, terms that you have in ontologies or in business vocabularies are a little bit different to what people would ask in a question. And if you have explanations around this is certainly something that can be helpful here. I think aggregates in statistics and analytics is something where we also have some tools coming up. You can already try it and ask, like, what's the highest project budget and so on, and what's the first start date of a project, and those things already work, but that's obviously different, more difficult.
Will it make use of synonyms defined in the ontology for the challenge, and what annotation property would you recommend for expressing those synonyms?
I think you can configure this in Metafactory. Out of the box, we use DC terms description, Dublin Core description. out of the box, but that's something you could also configure if you want to have others use. I mean, all the tools that we have seen here, we've seen under the hood, like the ontology, description tool, and so on, can be configured to also use them if you have some specific properties that you want to explicitly have used in that. Yeah. Okay. Yeah.
If your question adds more context, does it change the answer?
Oh yeah, definitely. If you provide more input, you say I'm specifically interested in these kind of skills and so on. Absolutely. Everything that you provide in there will help. And this is actually also something that you can tweak that we see here. That for each tool, you can modify the task instructions and also provide already examples for a specific use case. As we have seen in the framework, you can define several agents and you can tailor one of them, for example, for a very specific task. Have a different entry point for this agent, a different conversational AI interface, and say, hey, for this because it's a reoccurring task, it's very tailored to a specific domain, specific kind of question, and you can provide examples in the task instructions, and that actually helps them a lot. Yeah. Good. What other optimization things? You can actually, in the ontology, mark certain elements that's not needed. Yeah? So if you remove clutter that is not needed for your use case, that makes it easier to interpret. And also it saves you maybe some money because at the moment, these LLMs have a token-based models, or depending on the number of tokens that you transmit your build. And if you remove some, you can save some tokens. And then obviously, another thing is to add namespaces that you make use of to your registry. This also shrinks everything. The use of namespaces helps you with less data transfer. Now, we have seen sometimes...
Can you expand on that last one about namespaces?
Yeah.
We're not adding namespace. Doing namespace prefixes?
Yes, that's right.
Different.
Yeah. So in Metafactory, we have RDF namespace prefixes.
Yeah, it makes sense now, say prefixes.
And you can...
The long things of a namespace.
Yeah.
Look at that table, the long things of a namespace.
Yeah, correct. Okay, so we have seen from time to time the questions are not what we expect. And we also have seen that LLMs are not deterministic. So sometimes it works, sometimes you are maybe unlucky and you don't get the answer that you intended. And in order to be able to assess this and show it and monitor it over time, our agent framework comes also with an evaluation framework that allows you to define test cases and evaluate them to measure the quality of your results. This allows you, for example, to compare different large language models. If you want to see the performance for AI versus Mistral or whatever, and see how they compare. You can compare them for different tasks. You can compare them for different agents. You can compare different agent configurations against each other and also other configurations that you're interested in to see what their impact is. You can define test use cases and then do them. And also you can collect user feedback. You might have seen this already. I ignored it and jumped over it. But if we go back here and ask a question, for example, who works on the Blue Sky project? Then what you can do is you can elicit from your users if they're happy with the result or not. At the moment, we just log this, but obviously in the future, there are also plans to make more use of this, but at least it gives you already some feedback to see this. Yeah, you can see this down here. You can say, okay, I'm not happy with the result, or I'm happy with the result, and then provide feedback. And you can also give reasons, right? I'm happy by completeness and so on, or I'm not happy by completeness or timeliness or correctness and so on. And what you can do is you can create a test case from it. Yeah, so you just click on create test case and then jump to it. I already have created this one, so I'm just show you this one. If we go here to conversational AI evaluation dashboard, then you can see here in this case, we have 3 test cases. We have a test case for what is the budget for Blue Sky, which projects are running right now, and who works on the Blue Sky project. If I create a new test case, I just basically have just a template of the test case. It's not created at this point in time, but if I go into it and actually have a look at it, I can basically see what was the conversation for this use case. And it can be several questions and responses that make up the conversation. And then I can go in here and also say, okay, I created this test case. on this target data set, it uses this ontology. The user, it's the speaker here, asked this question, and then the system returned this thing here, and I could have more questions and more responses, and then basically have a full conversation as a test case. And then I can obviously also just click on it and execute it. And I can combine different test cases into test sets and run them all together. So here I have one test set. It combines those 3 test cases that we have seen. I could execute the whole test set. And then I can go and obviously, if you do this, we have several pilot customers that are currently using this. They have then a whole bunch of questions and they are testing different setups and different zones. So you have very easily and very fast quite a lot of test cases. And then you can sort them by creation date and then find the test that you're interested in. And then you can see here that you can run test executions. So you can see the result of it, of a test run, and then also see a summary and see, okay, so 4 times we had a success for this test case and once it failed. And how do we determine failed or success? This is obviously done manually. So you have here, you have the actual test results for a question, for example, for what is the budget for Blue Sky. And then you go in here, you see the dialogue, question and the answer by the system. And then you can say, okay, this is a success here. And this response is success. And if you have a conversation with several responses, you can say, okay, the first 2 were success, the last one was a fail, and so on. So very detailed feedback on the conversation that allows you then over time to monitor the quality of the agent. Any questions on that part? I guess pretty obvious what's happening here, but actually very, very important. At the beginning, this was for us just an internal tool, and we just thought, okay, we just need this to develop it. But once our customer learned about it, found this also very interesting on their side because it also helps them to monitor and evaluate the performance. Okay, then brief outlook and on federated enterprise knowledge graph. So I told you that we, in our scenario, already distributed the modeling to different departments, and they worked on their data. But here in our tutorial instance, in the end, all the data was in one repository and one database. But actually in an enterprise scenario, this is obviously not the case. It does not need to be the case. There is the option to also distribute this. And we have in our platform federation engine called FedEx. We have currently still investing into also making certain use cases, not all of them, but certain retrieval use cases distributed with what we call model-driven source selection. So basically we say this ontology here, this is the HR, this is the project management office, this is really finance. We have an ontology that's perhaps this, we have an ontology that describes this department, not an ontology for this one here. Logically, they are all connected. And then we have here our agent sitting, knowing that if I have this part of the question that I want to derive, say the skills for people, they are in this repository. So this part I need to route to this piece of the knowledge graph. And then I have projects, and project requires skills. This is the project management part, this is here, and then retrieves the results from different places and combines them and then provides you the answer. And we have a blog post just published on this with some further reading on this. And it's something strategic topic for us to develop. Yeah.
It seems a bit odd splitting out by ontology. For example, I'd expect, let's say you've got different countries, you'd have an HR department for Germany and HR department for UK, etc. So you want to reuse the same HR ontology, but have distributed graphs, which you may or may not want to query for different countries.
Yeah. Very good question. Well, you can still use the same ontology for both things. You just have then in the source selection that both sources, that 2 of these sources are potential candidates for answers, and both of them will be queries.
You can reuse an ontology across multiple.
You can. Yeah. Okay. So brief summary of what have we seen so far of our agent framework Metis. We have seen it's quite easy to use. Yeah. We have a conversational interface which already allows widespread usages, different kinds of questions. It provides contextual answers that are grounded in the knowledge graph. We avoid hallucinations as good as we can by creating intermediate SPARQL queries that I run against the knowledge graph and retrieve results from your knowledge graph. You can explain the answers. We also have an evaluation framework that allows you to validate results, correct them, and improve over time. And this is a framework that you can use also in your enterprise, make it specific to your enterprise domains and retrieving data from your in-house data sets. Now we were on a very small knowledge graph, couple of triples, some small examples of ontologies. Now let's show you also that this technology can actually run on a much larger scale. I'll show you a very brief snippet into the dimensions knowledge graph, a knowledge graph of 33 billion statements, so really big. It comprises 150 million publications, scientific publications from our mother company, Digital Science. They developed this dimensions product. It contains patents, grants, clinical trials, researchers, organizations. These scientific publications are also annotated with concepts, so like what kind of genes occur in them, what kind of proteins, and also we use AI to detect certain relationships between these entities. And now put this all together in one big knowledge graph, and now we can ask very specific scientific questions against it. So it's the same technology that you just have seen, dimensions knowledge graph. And then the conversational AI. And you can see it already, okay. I can show you my previous conversation. So for example, I can ask a question now, is there a paper about AKT1, APP1? Show me a table. So these are two genes, very specific question. And you see it's the same technology. Now we get as a result here two papers referencing those two genes here and here. And we can see, okay, the title looks similar. Then we can ask the question, show me their authors, publications, and date. And then we actually see, okay, there are two publications with two different publication dates. You can see the authors. It's the same technology, same what you have just seen on our mini tutorial example, but now on the scale of 33 billion statements. Yep. Okay. Thank you for your attention.